ओके, मुझे पता है कि कई लोगों की एक कंप्लेन आई थी मुझे। कंप्लेन क्या, मतलब कुछ लोग आके बोल के गए थे, सर आपकी वो लास्ट वीडियो में ऑडियो नहीं आ रहा है, किसी में वीडियो नहीं आ रहा है। आई कैन अंडरस्टैंड, इट्स ऑल टेक्निकल प्रॉब्लम एक्चुअली। इसलिए मैंने ये पूरा रिवीजन वीडियो बना रहा हूँ। वैसे मैं बनाता ही हूँ, पर ये थोड़ा ध्यान से बनाऊँगा। 1.1 इंट्रोडक्शन का मैं पढ़ा चुका हूँ, 1.2 से स्टार्ट करेंगे। बाइजिंग ऑफ पीएन जंक्शन डायोड मीन्स when we are connecting a PN junction diode to a battery it is biased, means उसको हम unbiased नहीं कह सकते हम। Now it is a biased diode. It can be of two type, forward or reverse bias. When you connect P side to the positive terminal and N side to the negative terminal, it's called forward biasing. When the current flowing through the circuit is known as IF or forward current. The resistance in this circuit is forward resistance. As you can see in the circuit, the holes on the P side and the electrons on the N side now will go towards the depletion region, and the width of the depletion region will decrease as and when, and then the current, and there will be a point when this depletion region vanishes and the current flows normally through the PN junction diode. So after some time it vanishes, increasing the forward bias. The width of the depletion region decreases, and so does the barrier potential. As the depletion region width decreases, the barrier potential decreases. The flow of electron current, the flow of direction in which electrons are going, is opposite to the direction of the conventional current, as you can see in the figure 1.2.3. You can draw this diagram. If it shows that Vf means forward voltage is nearly equal to the voltage that we need to the breakdown voltage. Vj is nearly equal to Vf. That's what here we are trying to say. In the reverse bias, the P side is connected to the negative terminal and N side is connected to the positive terminal of the battery. The diagram shows it all clearly, and the current is called IS, or the saturated reverse current, reverse saturation current. Here the width of depletion region keeps on increasing. As you can see, the electrons move towards the positive terminal and the holes move towards the negative terminal from P side and N side and P side respectively. So the current here is all due to the minority carriers. Although there are majority of holes on the P side and majority of electrons on the N side, but there are still some amount of minority carriers, or we can say some small amount of electrons on the P side and small amount of holes on N side that will start now flowing, and this results in the minority current. Minority electron flow is seen in the diagram. This formula tries to explain that the voltage, the resistance that we get in near the due to the diode is very much higher than the resistor that we another load resistor. So we can neglect the load resistor, and therefore VR is equal to V. All the voltage that we supply in the circuit will be resulting there. Then there is a breakdown as we have seen, there is a cut-in voltage in the forward bias. Here there is a breakdown voltage. There are two type of breakdown, zener and avlanche. In avlanche, there are free electrons present in the p-n junction diode. These electrons will now collide with some other electrons due to higher, and here the large amount of voltage is applied. So velocity of this electron is quite high. So now this quite high velocity electrons will collide with the electrons in the valence shell of atoms, stationary atom. Now this electron will come out, they will collide with other, and similarly we have feasible amount of electrons out there, resulting in the current. This is avlanche effect. In the zener effect, we see quite opposite effect, quite different effect, in which we have a heavily doped p-n junction diode, where due to heavily doped p-n junction diode, the electric field increases, and due to this increased field, the electrons come out. So if you compare them, so we need to apply higher voltage on avlanche and less in zener. But during avlanche effect, we can see the voltage increases quite rapidly. So there is current increase quite rapidly in this, and due to the increase in current, there is more of power supply. As the power supply increases, there can be temperature increase in the diode, and that can damage the diode. But if the temperature increase is controlled, then we can have a proper application of this diode. Remember this difference between barrier potential and temperature. As we increase the temperature, as we are increasing the temperature, barrier potential will decrease. This is what we have seen. Why? Because more number of electrons will come out, more number of electron hole pair will be generated, so the depletion region decreases, and as the depletion region decreases, the barrier potential reduces. Advanced concept about the reverse bias diode. In this we discussed about reverse saturation current, that if we increase 1 degree, just remember this formula here, that 7% rise is seen in I naught with the 1 degree rise in temperature. Due to this we have a formula, I naught is equal to I 1.07. and silicon versus germanium, we compare them. We seen that the silicon and germanium is 3 to 4 times more current, such reverse saturation current, as compared to silicon with the same characteristics of dimension and doping densities. Still we have, why does we have germanium higher? Because in germanium we have fourth free valence electron in the fourth shell, while in silicon it's in the third shell. So attraction between the nucleus is quite strong in silicon, while it's weak in the germanium. So forbidden energy gap is less in the germanium, and hence more electron can come through the conduction band as compared to silicon. In germanium, more electrons are there in the conduction band, so we have more current. But still we prefer silicon more. Why? Because the silicon saturation current for silicon is much lower. So if we keep on increasing the temperature, there is no much effect on its properties of the diode. I had given you an example of my laptop. Then we discussed the VI characteristics in the forward bias. Wait. We have cut-in voltage for that. Then we discuss about the VI characteristics in the reverse bias, then the combination of both. And we see that the both characteristics of the silicon and germanium diode. Silicon has low breakdown voltage, higher breakdown voltage and low silicon has higher breakdown voltage and higher cut-in voltage. We also compared these both. You can remember the table. We have seen what is bulk resistance. There is ohmic resistance applied in the that we get in the PN junction diode. We have seen the mathematical expression. I know I have not explained that. There is nothing great to explain in that. We have seen if we increase temperature, how the graph of the VI characteristics increase. If with the increase in temperature, the cut-in voltage decreases and the breakdown voltage increases. And yes, with every 10-degree rise in temperature, the reverse saturation current doubles itself. That's all for today.